Hi, today I'm going to talk to you about hemoglobin oxygen equilibrium and how high altitude affects it. Background information. Hemoglobin, also spelled hemoglobin with an A, is a protein that contains an iron molecule found in red blood cells. The primary function of hemoglobin is to transport oxygen into the tissues from the lungs where it can exchange for excess carbon dioxide, which is then transported back to the lungs. According to eMedicine Health, the iron molecules found in the hemoglobin is responsible for maintaining the red blood cells' shape. Structure. Hemoglobin is made up of four subunits, each containing a globin and heme group. There are two types of globins, alpha and beta globins. Amino acid chains fold by hydrogen bondings, which cause the structure to be secondary. Then a few secondary structures come together to create a three-dimensional structure called the tertiary structure. One hemoglobin molecule consists of two alpha chains and two beta chains. These four tertiary structures come together to create one molecule of hemoglobin, which is a quaternary structure. The iron molecule in the hemoglobin comes from the heme group attached to a globin group. The heme group is essential for the structural and functional purposes of the protein. According to Body Tommy, the heme group is an organic compound composed of a porphyrin ring with an iron atom attached to the center. It is responsible for binding to an oxygen molecule so the hemoglobin can transport it into the tissues. One molecule of hemoglobin can carry up to 4 oxygen molecules, one for every iron atom. Function. The function of hemoglobin. Once oxygen has reached the lungs, it diffuses into the capillaries where the red blood cells are. Once it has reached the red blood cells, the oxygen molecules binds to the iron atom in the heme group. Once one oxygen molecule has binded with one iron atom, the other 3 oxygen molecules gain a higher affinity to bind, and so they all bind until the hemoglobin is filled. One hemoglobin molecule can have 4 oxygen molecules. Once all the oxygens have attached, the hemoglobin is in a relaxed state. Now the hemoglobin travels through the bloodstream carrying oxygen to tissues that need them. At the tissues, there is a low pH because of the high concentration of carbon dioxide. This lowers the affinity of oxygen bound to the heme group, causing them to dissociate from the hemoglobin and diffuse into the tissues. The removal of the oxygen causes the iron ion to go back into its reduced form, and the hemoglobin is now referred to as a deoxyhemoglobin. After oxygen has been removed from the hemoglobin, the high concentration of carbon dioxide near the tissues comes in contact with the hemoglobin, and according to PETA, 20% of carbon dioxide attaches to the hemoglobin and travels back to the lungs. Once the carbon dioxide is bound to the hemoglobin, it is referred to as a carbaminohemoglobin. So here's a diagram of a hemoglobin. As you can see here, there is alpha chain 1, alpha chain 2, then there's beta chain 1, beta chain 2, and these 4 little circles, are the heme groups, and attached to them are the iron molecules. As you can see, iron 2+. It's the bloodstream. So how and why equilibrium is impacted. So here's the equation. And so this is a dynamic equilibrium equation as the forward and reverse reactions are equal. Equilibrium can be impacted by the amount of oxygen available. Other factors that affect equilibrium include temperature, volume and pressure, and the concentration of oxygen in this case. At high altitudes, the atmospheric pressure decreases. This means that volume increases and that the reaction will have to shift to the left to compensate for the loss of pressure. However, at lower altitudes, pressure is high, which means that the reaction will have to shift to the side where there is lower molecules, so the right. At high altitudes, temperature decreases because of the lower pressure. As temperature decreases, it causes the hemoglobin proteins to denature because proteins only work at an optimal range, and going below or above the optimal temperature range causes the protein to denature. This means that the reaction shifts to the right to increase the production of oxyhemoglobin. Lastly, the concentration of oxygen in the body has a significant impact on the hemoglobin oxygen equilibrium as well. At the lungs, there's a high concentration of oxygen coming in through cellular respiration. This means that to compensate for the high amounts of reactants, the reaction must shift to the right to produce more oxyhemoglobin and use up the excess oxygen that is coming through cell respiration. On the other hand, in the tissues, there's a lower concentration of oxygen, so the reaction must shift to the left to produce more oxygen to reach equilibrium. So, impact from a biological perspective. If a person were to go from sea level all the way up to the mountain, to the top of the mountain, they would most probably be unconscious because at higher altitudes, like I said before, the atmospheric pressure decreases, and according to Le Chatelier's principle, as pressure decreases, the reaction shifts to the side which has more molecules, which is the reactants in this case. Therefore, the reaction will shift to the left to compensate for the low amounts of oxygen molecules present in the air. This means that there is less oxygen going towards the brain and the rest of the body, which is very dangerous for the cells in the tissue. They need constant supply of oxygen to survive. This condition can also be known as hypoxia, which is when there is insufficient amount of oxygen pumping to the tissues in our body. Altitude sickness. So, symptoms of altitude sickness include headaches, vomiting, fatigue, and shortness of breath. For treatment, depending on the symptoms, you may have to seek medical attention. The main thing that you have to do, though, is to go down to sea level, depending on how high you are. According to WebMD, if the sickness is severe, then going down to sea level is crucial and must be done immediately. Also, you should get medical attention for medications that you may need. Lastly, a connection I made. So the Canadian Blood Services is a very large organization that helps with transfusion and transplantation medicine. It was founded in 1998 and is a non-profit organization that helps all provinces and territories within Canada. Their goal is to supply blood for people in need, and many people that have issues with blood cells and hemoglobin seek the Canadian Blood Services for help. So yeah, that's it. Thank you for listening to my presentation.